Okay, so welcome to all of you. Today we'll see the mean value theorem. So there are three mean value theorem. First one is Rolle's mean value theorem. Second one is Lagrange's mean value theorem, or simply the mean value theorem. Okay, so mean value theorem is also called as the Lagrange's mean value theorem. Okay, and third is Cauchy's mean value theorem. So these are the three mean value theorems are there. So before that we'll see some definitions. So these definitions are useful while proving or in the theorems. Okay, so that mean value theorem, we want to prove that mean value theorem, so we need this the basic definition first. Okay, so what is the first definition? A function f from I is the any interval now. Okay, so closed interval ab or open interval ab, whatever this. Okay, so is said to, that means what, f is a real valued function. F is a real valued function defined on I is what, the interval in the or subset of the R. Okay, have global maximum at C belongs to R. So that means what, f of c is the maximum value among all the function value. That means what, f of c, see, f of x is less than or equal to f of c. So f of c is the biggest value of all x belongs to I. Okay, so if you value the any value of the function at x, so you see that f of c is the biggest one. Okay, so then that f of c, so that means what, the function has a global maximum at x. That means f of c is the global maximum value of f. Okay, similarly the minimum value means what, f of c is the smallest value, then it will be the global minimum value. Okay, f of c is less than or equal to c, or less than or equal to f of x. That means f of c is the smallest value of all the functional value at x is equal to at x. Okay, so then the f of c is called a global minimum value of f. Okay, so extreme value means what, either it is maximum or minimum. Okay, so we said that f has global extremum at c belong to R if it is a global maximum or global minimum. Okay, so extreme value means what, either maximum or minimum value, it is not even. Okay, now next again this is what, relative of local minimum. This is the global minimum. This is the same thing here also. There exists delta, only this part is there. There exists delta greater than 0 such that, see, this is also f of c is the greater than f of x. So global maximum value this. So in this interval c minus delta, c plus delta, that means in the neighborhood of c. This is nothing but a neighborhood of c. Because c is in the interval I, so that means this intersection is what, actually this is the subset of I. So intersection is c minus delta, c plus delta. Okay, so same thing for the local minimum value. C, f of c is the smallest value. Here also f of c is the smallest value. Only we have changed here. Okay, relative. Again the relative local relative extremum or local extremum is what, it is either local maximum or local minimum, or relative maximum, relative minimum. Okay, this is a very important theorem, interior extremum theorem. That is what, let's see with the interior point of this. Interior point means what, interior point means what, so this. Okay, interior point means what, it is belongs to the open interval AB. It is belongs to the open interval, not a boundary point now this is. Okay, so here see, that means what, if you take any neighborhood of this, so that neighborhood contain in that set. Okay, so any neighborhood of the C is contained in that interval, so this is called interior point. Okay, so see the interior point of I, and then has relative extremum. That means C have a relative extremum. Okay, so if derivative at C exists, then it is 0. So derivative, first derivative at c is 0 if it is a relative extremum or minimum. So you know that the function has maximum value or minimum value, then the first derivative vanishes. So we are familiar with this one. So same thing also here. Okay, so if f prime c is not equal to 0, if f prime c is not equal to 0, then it has neither maximum nor minimum. So that means no relative extremum. Okay, so that means what, if f prime c is not equal to 0, then it has neither maximum nor minimum. Now we go to our main Rolle's mean value theorem. Okay, so first we will see Rolle's mean value theorem. After that we will see the Lagrange's mean value theorem, and after that we will see the Cauchy's mean value theorem. So these are the three mean value theorems. Okay, so not this is simple R. Rolle's mean value theorem. Rolle's mean value theorem. Okay, statement. Let f from closed interval AB be a function such that that means what, f from closed interval AB to R. This is very important. Be a function closed interval AB to R. Okay, that means f is a real valued function defined on closed interval AB such that one, f is continuous on closed interval AB. Second, f is differentiable on open interval AB. And third one is f of A is equal to f of B. So these are the three conditions. Okay, f is a continuous on closed interval AB, differentiable on open interval AB, f of A is equal to f of B. That means what? At extreme, so that means A and B are the extreme points of the interval AB. Okay, so they are equal now. F of A is equal to. Then, if these conditions are followed, then there exists C belongs to, that means C is the interior point of open interval AB. C is closed interval AB. Okay, there exists C belongs to AB such that f prime C is equal to 0. F prime C is equal to 0. Okay, so this is the important statement. F is a continuous on closed interval AB, differentiable on open interval AB, and f of A is equal to f of B. Then there exists C belongs to AB. Okay, such that f prime C is equal to 0. So okay, so we'll prove this one. Prove. Let g of x is equal to f of x minus f of A. F of A. Okay, so g of A is equal to f of A minus f of A is equal to 0. Okay, so g of B is equal to f of B minus f of A, minus f of B minus f of A. But f of A is same as f of B. Okay, so this is what? F of B minus f of B. So this is equal to 0 because we have provided that f of A is equal to f of B. Okay, so therefore g of A is equal to g of B is equal to 0. So therefore, as f is continuous on closed interval AB and differentiable on open interval AB. This implies that G also continues on open interval AB and differentiable on open interval AB. Okay. So and G prime x is equal to f prime x. Okay, so if we differentiate this, derivative of f of a 0. Okay, so derivative exists, so therefore G has a maximum or minimum at some point x1 x2 and okay, we'll say and at some point x1 x2 respectively in closed interval AB. So that is g of x2 is g of x, g of x1. Okay, we may say this for all x belong to OB, because what, G has maximum, this is maximum, G has maximum at x1 and minimum at x2. That means G of x2 is less than or equal to G of x, and G of x1 is greater than G of x. Okay, so this is what now here we have to prove this theorem. That means we have to prove that f prime c is equal to 0. Okay, so that is our aim now. Okay, case 1. If G of x1 is equal to G of x2, then that means what, maximum value is same as minimum value, then G of x is constant function. Okay, so therefore G prime c is equal to 0. G prime c is equal to 0, or G prime x is equal to 0 for all x belong to closed interval AB. Okay, open interval AB, no problem this. Okay, so therefore G prime c is equal to 0 for c belongs to open interval AB. Okay, so first part is over. That means what? So if G of x1, that means if maximum value is same as minimum value, then function will be the constant. Suppose now say case second, G of x1 not equal to G of x2. So G of not equal to, that means what, G of x2 is strictly less than G of x1, because what, here less than or equal to there. Okay, so G of x2, because this is the smallest value and this is the biggest value. Okay, so that is G of x2 is less than or equal to G of x2. Okay, then either G of x2 not equal to 0 or G of x1 not equal to 0. Suppose that G of x2 not equal to 0. G of x2, again sir, see, if, okay, so G of x2 not equal to 0, so that x2 not equal to 0, x2 not equal to A, x2 not equal to B. Okay, so what, why this is what, G of x2, see, G of x is what, G of A is 0, G of A is 0, G of B is also 0. If G x2 is equal to A or x2 is equal to B, then what, this will be the 0, then G of x1 or G of x2 will be the 0. So x2 cannot be A and x2 cannot be B also, because G of A is 0, G of B is also 0 here. Okay, so we don't want 0 now. That means what, x2 cannot be A and cannot be B. Okay, so then we have seen the theorem that what, so this is what, derivatives exist, then so hence by interior, exterior, extremum theorem, we get, because x2 is the interior point. Okay, x2 is the interior point of this, we get G prime x2 is equal to 0. G prime x2 is equal to 0. So G prime x2 is equal to 0 means what? Because G prime is same as, so therefore f prime x2 is equal to 0. x2 belongs to open interval AB. x2 belongs to open interval AB. Okay, so let x2 is equal to C. So f prime C is equal to 0 for some C belong to open interval AB. Okay, so now see the theorem is over now. Okay, so similarly we have taken that G of x2 not equal to 0. Okay, similarly if we take G of x1 not equal to 0, then we will prove f prime x1 is equal to 0. Okay, so this is the end of the theorem. So one thing is very important, that geometrical interpretation now. So this is very important. This is very important. Geometrical interpretation. Geometrical interpretation of simple R now this Rolle's theorem. So Rolle's mean value theorem is simply called as Rolle's theorem. Okay. So that geometrical interpretation is, suppose okay f let f is continuous, let f be continuous on closed interval ab and differentiable on open interval ab and f of a is equal to f of b, then there exists C belongs to open interval ab such that the tangent at x is equal to c is parallel to x axis, because we know that parallel to x axis. So the slope of the curve was y1 minus y2 upon x1 minus x2. Okay, so you know that the points on here, the slope of x axis is 0. Slope of x axis is 0, and any line parallel to x axis is also any line parallel to x. The slope of the any line parallel to x axis is also 0. Okay, you know that the two lines are parallel, then their slopes are same, and if two lines are perpendicular, then product of the slope is -1. Okay, the same thing here. So that means what, and you know that, so d by dx f of x at x is equal to a is nothing but the slope of the tangent at x is equal to a. Derivative at a point is nothing but the slope of the tangent. That means what, f prime a is the slope of the tangent to the function f of x at x is equal to a. Okay, and see, this is what the slope is 0. That means what, the tangent at x is equal to a is the parallel to x axis. So for example, so you can see the geometrically the function is continuous like this. Okay, at least one c now. See, this is at least one c now here. The function is what here? The continuous. You see the function is continuous here. There is at least one. There may be more than one. Okay, more than 2 or more than 2. Okay, c such that lies between such that derivative is 0. Okay, so this is the geometrical interpretation of the Rolle's mean value theorem. Okay, so now we will see some problems on the Rolle's mean value theorem. Okay, so we'll see one by one problems on it. So problems are very important here. Okay, so it go one by one problem. Example 1. Okay, suppose f of x is equal to mod x. X belongs to closed interval -1 1. Okay. Okay. Solution. Given that f of x is equal to mod x. X belongs to closed interval -1. So these are the so what we want to first see, whether the Rolle's theorem is applicable for this function. If Rolle's theorem is applicable for this function, then you have to find a value of c such way that your first derivative is 0. Okay, you have to find a value of c belongs to this -1 1, right? Such that your derivative is vacant. Okay, we know that f of x is equal to mod x is not differentiable at x is equal to 0. At x is equal to 0. And 0 belongs to open interval minus 1 1. Okay, minus 1 1. Okay, so thus f is continuous on closed interval minus 1 1, but not differentiable on open interval minus 1 1. Open interval minus 1 1. So therefore Rolle's theorem is not applicable. Okay, so Rolle's theorem is not applicable here. Suppose you see that, suppose this is 0 1, suppose we'll say take the interval 0 1. Okay, so now if it continues on, okay, if the mod x is continuous very well, no problem for this one. Okay, so continuous. This is also differentiable because when open interval 0 is not there. Okay, so if there is an open interval 0 1, so then what, it is continuous on closed interval 0 1, differentiable on open interval 0 1. But see, what is f of 0? F of 0 is 0 and f of 1 is 1. That means f of 0 is not same as. So for third condition of the Rolle's theorem is what? F of a is equal to f of b. Okay, so now if you consider this, okay, second example, okay, f of x is equal to mod x belongs to 0 1. Okay, so f is easily you can say f is continuous on 0 1, differentiable on open interval 0 1, but f of 0 not equal to f of 1, because f of 0 is 0, f of 1 is 1. Okay, so therefore Rolle's theorem is not applicable. Okay, so one thing we will note also that, so right derivative f prime plus x is same as f prime at 0. Okay, so this is 1 and f prime minus is minus 1. Okay, so that means the right derivative of f at x is equal to 0 is 1, left derivative at x is equal to 0 for mod x, this is minus 1. So left derivative is not same as right derivative, therefore this is not this is not for you only. Okay, so what is the right derivative of mod x at x is equal to 0 is 1. Okay, similarly if f of x is equal to mod of x plus 1, so for x is equal to minus 1 it is 0, for x is equal to minus 1 it is 0. So that means what, this is not this, what is the f prime plus 1 now, f prime plus 1, so f prime minus 1. Okay, so that is what, limit x tends to minus 1 plus f of x minus f of minus 1 upon x minus 1. Okay, so x tends to minus 1 means what, x plus 1 is positive, means x plus 1 is positive. X is greater than minus 1 means x plus 1 is positive. So this is what, x plus 1 minus 1 upon we will take h tends to 0, plus x tends to 0 plus f of x plus f of h plus h minus 1 minus f of minus 1 upon, that also right, no problem for this one. Okay, so this is what, x tends to minus 1 plus f of x minus f of minus 1 upon x plus 1 now here. Okay, so this is equal to limit x tends to minus 1. This is x minus 1. This is x plus 1. Okay, because what? X tends to minus 1, that means x plus 1 is positive. X plus 1 is positive. Okay, because x is greater than minus 1. X is greater than minus 1. X is greater than minus 1 means what? This is minus 1 is 0. Greater than minus 1, that means it is here. That means x plus 1 is positive. See, x is greater than minus 1 means x plus 1 is greater than 0. That means x plus 1 is positive. And what a positive number is itself. And minus f of minus 1. Minus 1 plus 1, this is 0. So this is 0 upon x plus 1. So this is what? 1. This is what? 1. So that means what? The right derivative at x is 1 is 1. And what is the left derivative? Left derivative is minus 1. Same thing here. Same thing here. Okay, same thing here. What? Left derivative is minus 1. Right derivative 1. So for x plus 1, this is also same now. Right? So it is not 2 now. Okay, so now we'll take a next example. Next, second example, f of x is equal to x square plus twice x. X square plus twice x. X belong to closed interval minus to 0. Okay, solution. F of x is, now this is a polynomial function. Okay, f is a polynomial function. Now we know that a polynomial function is continuous everywhere, differentiable everywhere. Okay, so therefore f is continuous on closed interval minus to 0 and differentiable on open interval, even though it is also differentiable on closed interval minus to 0, but we want open interval. Okay, so then, okay, so what we have to find? F of minus 2. F of minus 2. What is f of minus 2? 4 minus 4. This is 0. Okay, what is f of 0? F of 0 is 0. So therefore f of minus 2 is equal to f of 0. Okay, so therefore Rolle's theorem is applicable. That means what? Rolle's conditions are verified. Rolle's conditions are satisfied. You may say that Rolle's conditions are satisfied here. Okay, so these are the three Rolle's conditions. First one is what? Continuous. Second is what? Differentiable. Third is what? F of A is equal to f of B. If these three conditions are hold, okay, are verified, then you say that this function satisfies the Rolle's theorem, or Rolle's theorem is applicable. Okay. Okay. So we'll find a derivative now. F prime x is equal to twice x plus 2. Okay. So f prime c is equal to 0. So twice c plus 2 is equal to 0. C is equal to what? Minus 1. Okay, and if it belongs to the interval, it should belong to the interval. If it is not belong to interval, that means Rolle's theorem is not verified. Okay, now see, this is belongs to the open interval 0 2. This is the open interval 0 2. Therefore Rolle's theorem is verified. See, you get the C, value of the C, at least one value of the C, at least one. So if there are more than one values of the C, then at least one value of C should belong to the open interval. So we have only one value, it must belong to the interval. Okay, so C, this belongs to the interval. Okay, so we are true. So that means your C is what? Minus 1. Value of C is very important here. So C is the minus 1. For objective they will ask this what? If this is the, then the value of C is what? Just you have to differentiate this twice. Okay, directly you can do this one. Twice x plus 2 is equal to 0. So x is equal to minus 1. So your C is what? Minus 1. Okay. So C means x. No problem for this one. Okay. So we'll take the next example. F of x is equal to f of is equal to x square minus 6x plus 8 on closed interval 2, 4. Okay. Find C by Rolle's theorem. Find C Rolle's theorem. Okay. Solution. We'll rearrange this. Find C. Again, this is a polynomial. Okay. So f is a polynomial function. Therefore, f is continuous on closed interval 2, 4, differentiable on, we'll write open interval, it is also differentiable on open interval also. These two conditions are verified. Okay. So the third condition was f of a is equal to f of b. So f of 2 is what? 4 minus 12 plus 8, this is 0. So what is f of 4 then? This is what? 16 minus 24 plus 8. Again this is 0. So f of 2 is equal to f of 4. Okay. Therefore, Rolle's conditions are satisfied. Okay. So therefore, Rolle's theorem is, we will directly say that Rolle's theorem is applicable. One of these you write this. Okay. So we'll find a derivative now. Okay. So f prime x is equal to twice x minus 6. Okay. So f prime c is equal to 0. Implies that twice c minus 6 is equal to 0. So c is equal to what? 6 by 2 means this is 3. Okay. And this is belong to open interval 2, 4. Right. So you want the value of c. C is 3. Okay. For objective, be ready for this one. So if the question is by Rolle's theorem, the f prime c is equal to 0. The value of c for f prime c is equal to 0 is, just you have to differentiate this. Twice x minus 6 is equal to 0. That means what? Twice x is equal to 6. X is equal to 3. And that should belong to the open interval whatever we provided to you. Okay. So easily you can find the value of c now. Orally also you can find the value of c. Okay. So we'll take the next problem. F of x is equal to root of 1 minus x square on minus 1, 1. Okay. So we'll check whether the Rolle's theorem is applicable or not. We'll see the Rolle's theorem is applicable or not. Okay. So first we will find the derivative of this one. Okay. So first we will do the f prime x now. So this is what? 1 upon 2 root of something into derivative of something. Right. So this is what? Minus x upon root of 1 minus x square. Now see the interval. So if you put x is equal to minus, this is positive. This is positive. And if your x lies between minus 1 and 1, then 1 minus x square is positive. Then 1 minus x square is positive. If your x lies, if this is minus to 2, then the function will not be continuous, because there are chances for get a root of the negative number, and root of the negative number does not exist. Okay. So the interval is minus 1 to minus 1, 1. If it is other than this minus 1, 2, then there are the chances to get a root of negative now. Okay. And root negative does not exist. So that means what? Your function will not be continuous, because the function does not exist at that point. Your f does not exist at that point. Here you have given the closed interval minus 1, 1. That means what? Here 1 minus x square is positive for all values of x lies between minus 1 and 1. So that means what? Your f is exist everywhere in the interval minus 1, 1. Therefore it is continuous on. Okay. So f is continuous on minus 1, 1. And so now the function is not differentiable. So this is the numerator upon denominator. If x is equal to 1 or x is equal to minus 1, this will be the 0. Your denominator will be the 0. So that means your function is not differentiable at 1 and not differentiable at minus 1. But we are in the open interval minus 1, 1. In the open interval minus 1, 1, your minus 1 is not there, 1 is also not there. So that means is differentiable on open interval minus 1, 1. Open interval minus 1, 1. Okay. Open interval minus 1, 1. It is differentiable. because this is not differentiable at x is equal to minus 1. This is not differentiable at x is equal to 1. But minus 1 and 1 are not in the domain of this. Okay, so not in this, not included in the open interval minus 1. So that means your function differentiable. Okay, so we'll find f of 1 now. F of 1 is see, plus or minus 1. This is 0. This is same as f of minus 1. Therefore, what Rolle's theorem is applicable. So therefore f prime is already we got this. Okay, f prime c is equal to 0. So that is what minus x upon root of 1 minus minus c. Okay, so c square is equal to 0. That means what c is equal to 0, and this is belong to open interval minus 1. Therefore Rolle's theorem is verified. That means if Rolle's conditions are satisfied, then there must exist c belongs to open interval AB such that f prime c is equal to 0. See, the c is equal to only one value there, and that is belong to the open interval minus 1. Okay, so this we are through here. We'll solve number of problems on it. We'll take more problems on it so that the idea will be clear to you. Okay, now we'll discuss the problem only. Okay, we'll discuss now. Okay, instead of this. Okay, so f of x is equal to x square minus 4x plus 3 upon x minus 2 1 3. Your closed interval 1 3. Okay, now see this, x minus 2 is there. Okay, so can you factorize this? So if 2 is there, then whatever 4 plus 3 is what? So that means this is not 0 by 0 form. This is not 0 by 0 form. Okay, now see here. Now this is not a continuous. This f is not defined at x is equal to 2, and 2 belongs to this interval. 2 belongs to this interval. Okay, so f is not continuous on closed interval 1 3, because what, f of 2 does not exist. F of 2 does not exist. So that means what here, Rolle's theorem is not applicable. Okay, so Rolle's theorem is not applicable here. So if the other than the interval, this what, if you take the other than, so for if you take this interval 0 to 1, okay, so now then this function is continuous everywhere. You see that if you take the derivative, it is also differentiable. But what happens, f of 0 and f of 1, okay, so f of 0 and f of 1 is not same, so Rolle's theorem is not applicable here also for 0 1. Okay, so the interval plays very important role here. Next example. F of x is equal to, just we will discuss now here, x square minus 3x upon x minus 1. Your interval is minus 3 0, suppose. Okay, so if 1 is there, so this function is not continuous at x is equal to 0, even though this is not differentiable at x is equal to 1 also. Okay, so that means if 1 is there in the interval, so Rolle's theorem will not be applicable. Okay, so now 1 is not there here, so now your function is continuous on this interval. Your function, if you take the derivative, your denominator is what, then x minus 1 square. Okay, so we'll just take the derivative now. Okay, so f prime x. So what is that? X minus 1 into derivative of the numerator, twice x minus 3 minus x square minus 3x upon x minus 1 square. Okay, so just we simplify this. So this is what, twice x square minus 3x minus twice x plus 3 minus x square plus 3x upon x minus 1 square. Okay, so that is what, x square. Your 3x get cancelled, so minus twice x plus 3 upon x minus 1 square. Okay, so if I make a mistake here, then the problem will be arising. So this is twice x square minus 3x minus twice x plus 3 minus x square plus 3x. Okay, so your 3x get cancelled. only there is a chance for this one. Okay, so now see, this function is not differentiable at x is equal to 1, but 1 is also not there. Okay, so that means what here, f is continues on minus 3 0 and differentiable on open. Okay, so actually closed interval, this is also differentiable. No problem for minus 1. Okay, minus 1 is there, but no problem for the minus 1. Okay, for x is equal to minus 1, it won't be 0. It is 0 only, your denominator is 0 only at x is equal to 1, and 1 is not there. Okay, so so what is the f of minus 3? You have to find the value of f of minus 3. Minus 3 is what? 9 minus 9 plus 9 upon 3 minus minus 3 minus 1. So this is what? 18 upon minus 4. Okay, so and what is the 0? Okay, don't find this. Okay, so f of 0 is equal to 0. So f of minus 3 not equal to f of 0, not equal to f of 0. So that means what here is not exist. Okay, so that means Rolle's theorem is not applicable. Rolle's theorem is not applicable here. Okay, so what happens if this is 0 1 0 3? For 0 3, see, Rolle's theorem is this condition is satisfied here. F of 0 is equal to f of 3, but it is not continuous, it is not differentiable. Okay, okay, so we'll take the next one. We'll take next problem. Suppose f of x is equal to x square. Your interval is 1 2. So what here? See, the polynomial function is continuous differentiable. What about f of 1? F of 1 is equal to 1. F of 2 is equal to 4. Okay, so f of 1 not equal to f of 2. Okay, so therefore Rolle's theorem is not applicable. Not applicable. Okay, no problem for this one. So what happened? This f of x is equal to x minus 1, x minus 2, x minus 3 on closed interval 1 3. Closed interval 1 3. Okay, so now this is a polynomial. F of 1 is 0, f of 3 is 0. You have to expand this for f prime x. For f prime x you have to expand it because f prime c is equal to 0. So now here what? The Rolle's theorem is applicable because this polynomial function is always continuous, always differentiable. Okay, and f of 1 is 0, f of 3 is also 0 because x minus 1, x minus 3, so this is 0. Here the Rolle's theorem is applicable. Okay, you have to find the value of c now. Okay, find expand this and this. Okay, now f of x is equal to ln of 2 minus x square on minus 1 1. Okay, so if you put whatever the value of this one, if you it is always less than, so your ln is positive. This number is always positive and not 0. Ln, because the log of 0 does not exist and log of negative number does not exist. So that means this is whole here. Okay, for x is equal to plus minus 1, so f of minus 1, so this is ln 1 is also 0, and for ln is log. Okay, so this is 1 is here, then 2 minus 1 is again 1, log of 1 is 0. That means here what? Rolle's is 0. Okay, so what is f prime x now? F prime x. Okay, we have checked here what? Function is continuous. We have to check the function is differentiable or not. Okay, so 1 upon 2 minus x square, 1 upon something into derivative of something into what? Minus twice x. Now here what? Your denominator is 0 and x is equal to root 2, and root 2 is greater than 1. Root 2 is greater than 1. Okay, so that means what here? The function is continued on open interval minus 1 1. Okay, no problem here. So the Rolle's theorem is applicable here now. This is Rolle's theorem is applicable here. Okay, so I hope that you understand this one. Okay, all the problems on the Rolle's theorem. Okay, so you get idea whether the Rolle's theorem is applicable or not. Okay, you can see the different functions. Okay, so I hope that you can do this. Okay, so we'll stop here. Thank you.